Hi everyone, my name is Kryssie Booth and my project is titled Built for Heat: How Southern California's built environment fuels extreme heat and urban vulnerability. Extreme heat is one of the fastest growing environmental hazards worldwide. So in this presentation, I'll explore how a hazard that seems purely meteorological, high temperatures and humidity, has become increasingly anthropogenic, meaning shaped and intensified by human development, energy use, and inequity. Extreme heat is categorized as a meteorological hazard within the climatological cluster. It occurs when temperatures and humidity remain unusually high for extended periods, exceeding local norms and stressing human health, infrastructure, and energy systems. In urban areas like Southern California, built environments of concrete, asphalt, and glass absorb and retain heat, producing what's known as urban heat islands. These zones can remain several degrees warmer than nearby rural or coastal areas, especially at night. Mitigation strategies focus on reducing exposure and vulnerability before these conditions escalate into disaster. Over the past 2 decades, extreme heat events have become more frequent and more severe across the globe. In Europe's 2022 heat wave, researchers estimate the number of heat-related deaths at roughly 61,000 people. The 2021 Pacific Northwest heat dome reached 46 degrees Celsius, about 115 degrees Fahrenheit, well beyond historical norms for that region. Here in Southern California, average monthly temperatures now trend about 2 to 3 degrees higher than in the early 2000s, meaning more days are crossing into the extreme heat threshold. This IPCC map shows global temperature anomalies from July 2018. The darker red highlights regions experiencing sustained record-breaking heat. Extreme heat is currently the deadliest weather hazard in the United States. Southern California's geography amplifies the heat hazard. The region's basins and valleys trap warm air, while dense urban surfaces store and re-radiate that heat after sunset. These urban heat islands create pockets of elevated nighttime temperatures that strain both infrastructure and human health. Impacts are unevenly distributed. Communities with fewer trees, limited air conditioning, and older housing stock experience the most dangerous heat exposure. In Los Angeles County, heat-related emergency calls have tripled compared to a decade ago. And areas that are more inland, like Compton or Riverside, can register 8 to 10 degrees hotter than coastal zones on the same day. These patterns overlap with historically redlined neighborhoods, showing how environmental and social inequities intersect. Extreme heat here is both a physical and social hazard, one built into the landscape itself. Extreme heat doesn't act alone. It's triggered by atmospheric patterns like heat domes and drought, amplified by human factors such as pavement, air pollution, and power grid demand, and compounded by related crises like wildfire smoke and respiratory illness. These overlapping effects reveal how extreme heat is largely an anthropogenic hazard. Its intensity and reach are driven by human design, resource use, and policy choices. The result is a cascade. Rising temperatures trigger heat waves, which amplify pollution and energy strain, compounding risks for health, air quality, and infrastructure. Mitigation focuses on reducing vulnerability before disaster occurs. According to the American Planning Association and FEMA, effective hazard mitigation integrates climate adaptation directly into community planning. For Southern California, this includes expanding tree canopy and reflective surfaces in high-risk neighborhoods, enforcing cooling standards for rental housing, and updating hazard mitigation plans every 5 years. Economic analyses consistently show the value. Each dollar invested in prevention saves up to 10 in recovery costs. These approaches also build community resilience by supporting cooling centers, early warning systems, and equitable access to resources. Extreme heat is both a symptom of climate change and a mirror of inequality. When we talk about being built for heat, we're acknowledging that the way we design cities can either protect people or endanger them. As Bankoff, Frex, and Hillhorst write, disasters are not acts of nature, but the outcome of how we build and live. Recognizing extreme heat as an anthropogenic hazard means acknowledging both our responsibility and our capacity to adapt. Reducing risk isn't just about cooling the air. It's about reshaping the systems that made our cities so vulnerable to heat in the first place. Thank you.